Hello, beautiful people. Welcome to my channel. I'm Amina, and in this prototyping series, we are building a YouTube video searcher, a tool that helps you to instantly find the information you need in a long video. Now, the front end is a Chrome extension side panel that allows you to type in your query. For example, English comedian, I typed it in Russian. As you can see, the video jumps straight to the point where they talk about James Page, English comedian. In this prototype, we are focusing on text-based search only, no LLMs, just embeddings, everything is running locally. As my expertise is in machine learning, I'll guide you through building backend. Now, frontend isn't my forte, that's why I've teamed up with ChatGPT, who's been my frontend developer. I'll also share how that collaboration worked. Let's talk architecture. This is how it looks on a high level. We kick things off with a data pipeline here that extracts audio from video URL and prepares data in a format that we can then transform into vectors, basically numerical representations of meaning, and put them in a vector store. Now, here's where the magic happens. Our front end sends a search request via post API search video with two key details, video ID and a query. API layer then digs into the vector store that finds most relevant content, and then API layer serves up the exact timestamp where the answer lives. Let's talk about each of the components in more details. Data pipeline has three main steps. Step 1, audio extraction that extracts audio from YouTube video using PyTubeFix Python library and saves it locally. Step 2, speech to text. I used OpenAI Whisper model because it's one of the most accurate open source models supporting multiple languages, including Russian, that I used for this demo. Step 3, data preprocessing and chunking. This involves extracting important metadata, for example, timestamps, and merging text into manageable pieces called chunks. This ensures that content is prepared for embedding and efficient search. Frontend is a Chrome extension side panel built using JavaScript. Now, you would ask, why Chrome extension? It allows users to interact with the video while watching it on YouTube, and it's a quick way to validate the idea. However, with 90% of YouTube visits coming from mobile devices, it's a logical next step to build a standalone app. API layer is built using FastAPI running on Unicorn. FastAPI offers clean and developer-friendly user interface. The Python ecosystem has support for machine learning libraries, and as a machine learning engineer, I'm most comfortable with Python. I used sentence embeddings model supporting Russian language, and after vectors are created, they are put in Milvus vector database. I chose Milvus because number one, I prioritize open source solution with minimal setup, and Milvus is an open source and handles much of the complexity behind the scenes, for example, indexing. Number two, the system should be able to scale if the product goes to production, and supporting large data sets and distributed deployment given the nature of the data, and Milvus is designed as a distributed vector database. Number three, the system should support hybrid search, meaning it should find semantically similar vectors and filter results based on the structured data, for example, video ID. I also use LangChain integration as it simplifies creating embeddings and querying Milvus that reduce my development time. Let's jump straight into coding. I packaged the all data pipeline and a vector database code in a video content search using Poetry. Let's build data pipeline now. And as a first step, we need to extract audio, which is very straightforward using this PyTubeFix package. And once we call this script with providing YouTube URL and output path, you should see audio file appearing in the dedicated path. As a step 2, we need to create transcripts based on this audio. Let's do it together in the terminal. While we are waiting, let's go and check Whisper GitHub page. As you can see, it has very good documentation. It's presented in multiple sizes with different performance. I use small model because it's quite fast and has good performance in Russian language used for my demo. So let's see if we've got results yet. And result is a dictionary with following keys: text, segments, and language. Let's see what's inside the text. So it's just plain text of the entire audio. But what we are interested in is the segments, because it provides important metadata for each of the segment. And what we're mostly interested in is the start and end, which are timestamps of this text in a video. Step 3 in a data pipeline is pre-processing, and the main goal here is to chunk transcribe text and put them into a list of LangChain documents, which is the class for storing a piece of text like this, hello world, and associated metadata. For example, source. In our case, it's gonna be timestamp and video ID. So we first load the transcription from JSON file, and we only extract data that we are interested in, which are text, start and end timestamps. And we create an object segments where we put this filtered list of dictionaries. And another useful function I created here is called load documents, that takes as an input list of these segments and outputs the list of LangChain documents. So pretty straightforward. Now there is only one part that we need to add here. Is if, as you can see in this example, the output of the Whisper model, these segments are quite short, which is not very efficient for vector database. So we need to consider putting larger chunks of text. Therefore, we need to concatenate the short segments into larger ones. Let me illustrate it with an example here. So imagine that on the left side, we have a list of the short segments as outputted by Whisper model, and then we decide to concatenate two subsequents into one. So this will be our output. So in the short ones, we have this find inside text and ask questions text with metadata start timestamp 0 and timestamp 10, and here it's 12 and 15. And as an output of this concatenation, we should get text find insights, ask questions with a start minimum of these two, which is 0, and end maximum of these two, 10 and 15. This is the loop that does exactly what I told. So it takes the segment objects, it could concatenates them into larger ones of different concatenation sizes, like 3, 5, 20, 50. You can choose anything you want. And then it passes it to the load documents function in order to create list of LangChain documents. Let's implement the vector store. And for this, we need to create a separate module. I created a module called vector store, put it in the search directory in the same Python package. I also created an abstract class with following methods: one for the adding documents, second is for deleting vectors, and provided that we know IDs of these vectors. Another method for deleting an entire instance of vector database, and finally the search similar that takes query as an input and returns list of tuples, where one element is long chain document and second is a score, similarity score. Now let's implement this Milvus vector store class together. I already initialized following attributes, which are embedding model name that I used for this demo. You can find the list of available models on the sentence transformer documentation. I used the multilingual version trained on 50 languages, which is quite good for Russian language. Also initialize the URI. It's where the vector database instance will be created. So LangChain provides very good documentation on its integration with Milvus. So you first need to install this package and then to create vector store to initialize it. This is the code that we can put here in init methods. We also need to create embedding model. Do it like this using sentence transformer embeddings package. All we need to do is to provide the model name, which is our self-embedding model name, and change URI to self URI here. Next up is add documents method. Again, let's refer to the documentation. It's pretty straightforward. So once we have a list of documents, and also it asks for IDs. It's not it's optional, but I guess for this use case it's better if we create IDs by ourselves, because ideally it should also contain the video ID in its full ID, because later it will be easier to find all vectors associated to one ID in case we want to delete it, for example, all by once. So let's change it to self.vector store, add documents and documents, your IDs, we have it here. So one thing that I want to change here is to also add video ID as part of this. For this prototype, we only work with one video. Let's just create some dummy video ID. Let me see, 1, 2, 3, something like that. Next up is delete vectors method. Again, this is the code from the documentation. We just make it self class attribute and change this thing to IDs. In order to delete the entire vector store, its instance, we can use the OS remove, I think, and provide URI, and maybe add some meaningful message saying database is deleted successfully. And for search similar, again, let's look what documentation says. I prefer to use this method, which is similarity search with a score that also provides similarity score. If we want, for example, to use some threshold on the output, then it will be more convenient. So, and we just return these results. The stores mentioned similarity search with score query. Now let's check how the code that we implemented works. We need to run poetry install to make updates to the package. And let's start Python session. So we need to import Milvus vector store class, pre-processing, in order to create documents that we can then feed to the vector store. And we also need this path. So let's create documents first. Pre-process, create documents, then path, wrap it in a path, and our data path is data transcription, booking, event, JSON. Then let's create the vector store object, Milvus vector store. And let's try adding documents. Good, so documents are added successfully. And now let's query it. So vector store. We need to call this method. Search similar. I'm going to use the same query that I used for demo, which is English comedian. And as you can see, we've got a list of relevant vectors, text and metadata. For example, if you look at the first result, you'll see that it's quite relevant for the query I provided. It talks about James Page again, which is English comedian, and provides start timestamp. Now let's build API layer, which is super simple. So in official documentation, you'll find this code, which says that we just need to create this object called app and then implement API with this functionality. I also used Pydantic for input data validation. So let's see how I did it. So we created app here, and this is our post API method called search video that takes as input following data, search request, which is a child from Pydantic base model, with following data, video ID, query, and user ID, and it returns video ID and timestamp. So for now, timestamp is 0, but we are going to implement this method together. Another interesting block here is this one that is configuring middleware. This code lists origins that are allowed to communicate to backend. To implement post API, let's create another function and call it search video for timestamp. That will take video ID, string argument, and query. And the output will be float, which is timestamp. And for retrieving vector database and identifying which result and corresponding timestamp should be returned, I created another module and video content search package, and it's called retrieve logic with the function search timestamp that queries vector store. And I used very, very simple logic, which is just taking the first search result and putting it all in a dictionary with following keys: timestamp, query, video ID, and message. And this is what we are going to use here. So this is where it's imported. Search timestamp. We should provide it with a vector store and query. And query. So let's initialize vector store here. Milvus vector store. And it returns timestamp. It returns result. Now let's put it in a try block. Try result except exception SE. Because in case something goes wrong, I want to know where it happened. Couldn't query vector database. And we also want to return none in this case if something happens. Otherwise, we return result get timestamp. So let's change this timestamp to result from the function that we just implemented, search video for timestamp, and we provide it with video ID and query. Again, if we see that timestamp return is none, we need to raise HTTP exception with the error code, status code, 404, and detail some message on what happened. Timestamp not found for the given query. So let's test it, run it, and test it. To run it, this is the command that we use. Okay, it's starting. Startup complete. Now let's send a post API request, and good. So it returns correct timestamp, which is 156 as we saw in the demo. I don't have much expertise in front-end development. That's why I've asked ChatGPT to help me with that. What was useful for me as a start, this Hello World extension tutorial from Google that helps to build very basic extension and test it in extensions page. So I had to load the package and turn on the developer modes. Another example that was useful is the site-specific side panel example from Google Cookbook. I then shared all this code with ChatGPT and asked it to modify it in order to create a Chrome side panel where a user can enter the text and get a response that is a result of calling the API that returns timestamp, and then it should create also a clickable YouTube URL. What was really efficient was to ask ChatGPT to do this development step by step rather than all at once. I didn't get much errors, but when I did, I just shared it with ChatGPT and it corrected itself. Now, the front end has a following file called sidepanel.js, and this is where the API is called. Now that backend is up and running and frontend is ready, you can go back to the start of this video to see how it all worked together. See you next time.